Hi everyone, we are back with another Leetcode problem, and this is one of the problems within the blind 75 list. The problem is removing end node from the end of a linked list. Okay, so it's a straightforward problem. The problem definition says that we're given the head of a linked list and we have to remove the nth node from the end of the linked list and return the new node. So suppose in the first example, we are given this head of the linked list. That means once we have the head of the linked list, we can just follow the next pointers and we can go to the end. Okay, so from the end, we have to find the second node because the value of n is second here. So we have to find the second node, get rid of it, and then return this new list. For the example 2, we see that this one has only one node, and the value of n is also 1, right? So we have to find this one, get rid of this, and my resultant linked list is going to be a null. For the third example, we have like two nodes, 1 and 2, and then we have to find the first node from the end, get rid of it, and my result that linked list would be, the answer is going to be this, okay? So while solving the problems of the linked list, a few things that we always have to be very careful. These things actually cause a lot of problems. Suppose first, very carefully handling these null at the end. If we are not careful, null pointer exceptions will happen and our program will not run even. So it and the other thing that is important is uh, linked list doesn't have random access. I cannot jump to int node or any node directly. Whatever I do, as I have to start from the head and keep on going, right? Okay. So the problem here is, I think the only tricky part of the problem here is we have to find the nth node from the end, right? So from the end, we have to find the end node. And since this is a single linked list, we cannot go backward, right? We cannot go backward. So that's the problem. We cannot just go to the jump to the end. It doesn't have random access and keep on going backward. So we have to find another way. Let's think about this problem in a straightforward fashion. Let's say if the problem was find the end node from the front. What we could do is just say we could just go to the nth node. Say this is the nth node from the front. We could just go to the n minus 1th node, right? And then we can just take off this next and assign the next to the next, right? This was pretty easy. So let's think this problem as a forward problem. Let's say if we know that the length of the list, if we know that the length of the list is L, and we have to find the nth node from the backward, right? Can we say that the nth node from the backward means is L minus n? So from the, this is nth node from the back. So that means it is L minus n plus 1. This is node from the front. So can we say that? Yes. So this is L minus n plus 1th node from the front, right? Okay. So the same way, how do we get rid of this? So the way I'll get rid of this is we go to the L minus n and plus 1 minus 1. That means L minus nth node, we go to the L minus nth node from the front and then just do the thing that we are doing. Just set the next to the next, set the next to the next. So we get rid of this and assign this to the next. So the first pass is we have to know the length of the list, right? So we don't know the length of the list. Uh, what we do is we start from the beginning, keep on increasing the length, go to the next node until we reach the null. And that way we get the value of L. And then we calculate L minus n. And then we go to the L minus nth node and then do the stuff, right? So in two pass. First pass, I will just go all the way to the end to get the length of the list. And the second pass, I will go all the way to the L minus nth node and do my stuff. Okay, so here is one thing to notice here. Say for the second example, say this is 1 and this is null, right? Okay, so and we have to get the first node from the beginning. So here the value of L is 1, N is 1. So L minus N is 0. And as you see, we don't have any 0th node here, right? From the front. So that's actually we can handle it in different way. But for the ease of the problem, I think what you can do is we can keep a dummy node and make the head of the list the next to the dummy node and then start over here, right? So this way, actually the problem is going to be eased now. So this time you see that we can just come here and then we can get rid of these next, make a bridge here. And when we are actually finally uh, returning, we have to return the next. The reason is this is a dummy node, right? This is not the part of the original list. So this will make our problem much more easier to handle. So let's code this. List node dummy, create a new list node, and then make the current head as the next of dummy. So dummy points to the current head, and then we have list node current. We set it to dummy. We'll use this to get the length. We'll use this pointer to move. So on the first pass, we are trying to find the length of the list, right? So what we are going to do is uh, while current not equals to null, we increasing the length and current equals to current dot next. We keep on going to the end. So by now we have the length of the list, right? Okay, next what I have to do is for I will start over again from the beginning and then less than equals to n L minus n I plus plus. So this is the second pass where I'm trying to go to the L minus nth node, right? So before doing that, I have to reset the current. If I am using the same pointer, I have to reset it to dummy again. So starting from the dummy, I will go L minus n, go to the L minus nth node. Current equals to current dot next. Okay. So you see, when the value of I was 1, I am taking my thing to the second pointer, right? So this is important to notice. So the value of I is 1. For the value of I1, uh, just consider that the dummy is the first pointer now. We don't have any issue because now the length of the like length of the linked list will contain the dummy as well. Okay, so for I equals to 1, current goes to uh, the second node. Okay, so that means I have to do it. If I want to stop at the L minus nth, I have to keep on doing it until L minus n minus 1. That means after this step, this current pointer is going to be pointing L minus nth node. Okay, so my current pointer is pointing to the L minus nth node. Next, what I have to do is current dot next. I have to set it to current dot next dot next. And finally, I have to return dummy dot next because dummy wasn't the part of the original linked list. Okay, let's try to run this. Yes, this is accepted. Okay, so this is accepted and this was pretty fast. and the runtime of this algorithm is order of n plus order of n. So this is for the first pass where we get the length of the list, and this is for the second pass where we go to the L minus nth node and do our stuff, right? We solved the problem in 2 passes, but there is a follow-up question that if we can solve the problem in 1 pass. So obviously we can do that. Let's keep 2 pointers, first and second pointer, right? So at the beginning, we move the first pointer in places. So for this example, the first pointer is here, right? If this is here, why don't we move it, say, 2 places, 1, 2. So the first pointer is going to be here. Next, so the first pointer gets a head start with moving in places. Now the second pointer, after that, both of them actually move together. So next is first goes here, and the second starts from here and goes here, right? So this is second. Next, first moves to here, and the second moves to here, right? So this is the point where we stop, because we need to do my operation from here, right? So I have to get rid of this and created this. So I will start while first dot next not equals to null. So that means while first dot next not equals to null, I will just keep on moving. And once this is done, then I will just make second dot next to second dot next dot next. For the second example here, you see that this is important to handle the null clearly. So the first pointer is, if you want to move the first pointer 2 places, actually you cannot, because that's going to give you a wrong answer. So for that, what you have to do is, let's bring back that dummy node, and that will actually make things easier. So let's code this. Let's node dummy again. Set the head as the next of dummy, and then let's node first. This one is set to dummy first, and then the second, this is also pointing to the dummy. Now for int I equals to 1, n times I'm going to move the first pointer, and then I will start moving both until first dot next not equals to null. So that means now my second pointer is in place. I have to remove the next node from that. And finally, I return dummy.next, because dummy is not the part of the original one. Let's try to run this. This accepted. This was also pretty fast, and we have done it in 1 pass.